I can simplify a power raised to another power. Let me make sure my microphone's working. Okay, yeah, it definitely is. Um, Look, this isn't a very complex thing. It's just going to be another scenario where we look at simplifying exponential expressions. What do we mean when a power is raised to another power? Here it is in just English at least. It happens when you see an exponential expression inside parentheses. And on the outside of the parentheses are more exponents. So it looks like this. See this exponential expression right here? You have a base and an exponent, and it's all in parentheses. On the outside, there's more exponents. That's what we say a power raised to another power. Same thing here. We have an exponential expression inside of the parentheses, and we have an exponent on the outside. So we have a power raised to another power. How would you read it? 5 to the third power raised to the second power. How would I read this one? X squared raised to the fourth power, or x to the second power raised to the fourth power. That's how you would read these, and that's the reason I'm calling it a power raised to another power. We can simplify this type of scenario. Now, look at this. We have 5 cubed, or 5 to the third power, raised to the second power. What does that mean? It means that we have literally 2 of these 5 cubes, and they're multiplying each other. Now, remember, this is an exponent, and it's saying everything inside of this parentheses is happening twice. So we have 1, 2, 2 of these exponential expressions. And it is an exponent, so it means they're multiplying each other. So if you want, you could even put a little multiplication out there if it's not clear enough to you that they're just sitting side by side multiplying each other. Now remember, when they have the same base, and they're multiplying each other, we can just add the exponents. And so really it's 5 to the sixth power. Now, nobody likes doing this. What everybody likes to do is try to remember the shortcut. Well, that's fine if you can remember it, but if you can't, this is what it's showing you, and you can slowly and methodically get the right answer every single time. Maybe that's not good enough for you, but it'll get you the answer every single time. And so when I start to hear people confusing the shortcuts, normally I encourage you to go back and stop using the shortcuts for a while, because before long, the shortcuts make sense and it's intuitive. If you have no idea why the shortcuts work, if you have no idea how it works using the long method, you're usually doing yourself a disservice. Let's see. This simplifies to that. Notice the relationship of how we can get the 3 and 2 to form a 6? Yep, you're literally just going to multiply the exponents. So, yeah, there are 4 of these x squareds happening. X to the second power raised to the fourth power. That means there's 4 of them right there. So they're all multiplying each other. Add up all your exponents, 2, 4, 6, 8. The answer really is x to the 8th. However, you could just say 2 times 4 is 8 to keep the same base and you're done. Yeah, that's the shortcut. Multiply every exponent inside by the outside exponent. That's what's happening there. So it's not too hard and it's pretty easy, but you've got to keep it straight when you're having a power multiply another power or a power being raised to another power. Now, here's some different examples that we've not covered. How do we handle this? Well, everything has an exponent. If you don't see an exponent, it's a 1. And I'm going to tell you right now, if you don't see it, put the 1 in there, because now what we do is we take this outside exponent and we multiply every exponent on the inside. So what's 2 times 1? It's 2, so that's 5 squared. And what's 2 times 3? That's 6, so it's x to the 6th. Why does it work? Well, this is all happening twice. 5x to the third times 5x to the third. And on the previous lesson, I've taught you that these coefficients, these numbers in front of the variables, you just multiply those. 5 times 5 is 25. Well, what's 5 squared? It's 25. And what's x to the third times x to the third? It's x to the 6th. So there we have it. We've simplified this. A lot of times I'm asked, well, how do I know when to keep going with exponents? Well, if you know that 5 squared is 25, I'd put 25 down. If it's 5 to the 10th, or if it's 5 to the 20th or 5 to the 23rd or some large exponent that you don't know what it is, just leave it in exponent form. But if you can get there easily, please, by all means, go ahead and simplify it. Now, here, just make sure you multiply every exponent on the inside by the outside exponent. Let's see, that would be 10 to the 10th and m to the 15th. This would be way too large of a number to write, so we're just going to let that sit, and that is our simplified exponential expression. And don't forget the 1 for the 3. Everything has its own exponent. If you don't see one, it's a 1. 1 times 100 is 100, so it's 3 to the 100th power. And x has the exponent of 4, so 4 times 100 is x to the 400th power. Again, 3 to the 100th power is just way too large, so we're done with that. I've got these 3 practice and check problems. Pause the video, hit play when you're ready, and we'll go through it. Okay, how many of you got this? If you're happy, you rushed it, and you forgot that this 8 has a 1 for the exponent. So 4 times 1 is 4. And that's a little too large to go through there. Again, remember, inside the parentheses, it's like 8 times x to the 4th. And on the outside is this exponent. So that's the reason that we say this 8 has its own exponent of 1. It's not attached to the x, it's just multiplying the x. It's its own separate number. And if you're struggling with that, please, 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 please remember, if you don't see an exponent, put a 1 in there. That way you can actually multiply it. That's where people mess up. That's where people mess up with these types of problems. All right, here's the second one. 3 times 3 is 9, so that's 2 to the 9th. 3 times 20 is 60, so 2 to the 9th, v to the 60th. And here we go for 18. 2 times 50 is 100, so 10 to the 100th power. Didn't mean to make that little dot there. And 2 times 14, 2 times 14 is 28. Trying to show you my multiplication there. Is n to the 28th power. Hopefully, you can handle the problems that I'm about to give you. Good luck. If you've got any questions, let me know. Listen, questions are good. It'll keep you from being frustrated. If you're at home, how about you hop on my website and contact me, or use the remind feature, contact me, and I'll see if I can help you right away. This isn't too hard. It's just we've got to let you know where to multiply and how to rewrite the problem.